Very good afternoon and warm welcome to all the attendees and panelists. We all know the biggest challenge every food processing industry faces these days is the lack of advancement and innovation in its manufacturing practices. Now, to bridge this upgradation gap, we at Neologic Engineers decided to present an emerging food tech webinar series. In this webinar series, we usually talk about cost-effective food processing automation solutions and then applications of top-notch food machineries and technologies, and current trends and future directions in the food processing sector, and many other things. So we have been conducting these webinars since last 3 years, and in this 20th webinar of this series today, we will be talking about revolutionizing, modernizing, and expansion of an existing dairy processing plant. So, few words about our today's first speaker, Mr. Ravindra Mahajan, founder director at Neologic Engineers. He was born in middle-class family in Jalgaon, Maharashtra. He started his entrepreneurial journey and his association with dairy at the early age of 13 when he started selling milk early morning before going to school. He has masters in dairy and food engineering from IIT Kharagpur in 1991, with more than three decades of processing engineering experience, including years in Alfa Laval and Tetra Pak. He established his dream by founding Neologic Engineers with his fellow associate, Mr. Rajendra Gore, in 2007 to provide end-to-end solutions for various applications in dairy and food processing uh, industry. Mr. Rajendra Gore is also in the panel today. Uh, More about Mr. Mahajan, professionally a hardcore technocrat, PMP certified professional, having expertise in process design, plant automation, dairy aseptic systems, and project management. He has traveled to more than 30 countries and almost all part of India for his professional work. Welcome to the session, Mahajan sir. We look forward to your talks today. And let me also introduce our second speaker today, Mr. Shirish Kashyap, Business Development Head at Neologic Engineers. He's a mechanical engineer from COEP Pune with over 40 years of experience in dairy industry. He joined Alfa Laval in 1981 as a GET graduate engineer trainee. His professional work experience includes long stints in Alfa Laval, L&T, and Tetra Pak, covering functions right from project engineering, project management, till commissioning and product trials as well. His expertise are complete plant solution for dairy, ice cream, cheese, dairy products, and beverages, including utilities. Development of integrated aseptic line solutions for processing to packaging. His interest, he is a keen follower of current affairs, traveling, and music. So, ladies and gentlemen, let me present our first speaker today, Mr. Ravindra Mahajan. Over to you, sir.
Thank you, Nikhil, for a wonderful introduction. And this is really a very close topic to my heart because it's a challenging job as an engineer. And we have covered this topic 2 years ago, and we keep on receiving so many inquiries about modernization. So I thought, why not take up this topic again with some more insights and some more experiences we have gathered over the years. Thank you, and let's go through it. Yes, why modernization? Basically, we have this flow of discussion today. Why modernization? Why expansion? Challenges in modernization and expansion, methodology of upgradation, and then we will have one case study by the end. So, why modernization? So, many dairy plants were set up in India by NDDB and Amul as a part of the Operation Flood. And Operation Flood was at its peak momentum right from 1970s and 80s. And these equipments these systems and these dairies were installed with various cooperative state unions and local district unions, and it was really a big revolution when these plants came up in India and consumers started getting milk regularly as a nourishment. But these plants have become old and still running. Is it good? Not all old is not gold. Let's see why. Because there are equipment life issues. Basically, the energy efficiency factor is very important today. See, the old separators are consuming whatever power they are consuming today, as compared to the new separator, is almost double. Technological upgradation of such equipments like old homogenizers, separators, is not possible. Some of the tanks do not have provision to add instrumentation. Then these systems are old, so they are inefficient also, because now there are so many technological advantages happening. So the high processing cost is one challenge by running old dairy. Perishable industry risk is there, because there are chances that there will be sudden failures, sudden mechanical failures, maybe some sealing failures, some CIP failures. All these failures are a risk for a perishable industry, and sudden shutdown of the plant is totally disrupting the production and supply to the market, as well as you can't accept the milk unless and until there is a space in the dairy. So obsolete spare parts, basically these equipments now, though these are phased out by the original manufacturers, and you will have challenges in getting the spare parts. Another challenge is how to ensure that the production is done hygienically, because it is all operator dependent operation, and operator used to write the data and the production reports in logbook manually. So it is there is a manipulation of data possible. I have seen in some cases operator has marked in logbook that he has cleaned 4 silos in 1 hour, which is impossible, and that's clear manipulation. Utilities monitoring is difficult. So how my equipments are efficient, how much steam, water it is consuming, it's difficult to know. A lot of water is getting wasted, and water is a costly resource. Now, you may be familiar with such kind of flow plates. These kind of flow plates are quite common, because it is for the production person's flexible approach. He wants flexibility in taking milk from anything, anywhere to anywhere. Means from directly from raw milk to pasteurized milk, to silos to a balance tank, anywhere they want to take milk, and then they create such flow plates. And it is humanly impossible to remember which connection has gone under cleaning and which is missed out. So this is a hygiene risk. To fulfill statutory environmental requirements, it is very difficult. Means we have big losses, product losses, and all these product losses end up into our ETP load. And then we have problem in handling the so much of product in ETP. It is additional loss, but it is also a problem to treat. Growing demand to have MIS report. As I said, that manipulation of reports can happen. So we have to ensure that all the production events, all the production alarms are known to the management, as to know what is going well and what is not going properly as per the system. So here are some of the report samples. Now, these old dairies, you try to add capacity and you try to add new equipment. But when you add new equipment, even if you have a PLC control pasteurizer, it is difficult to integrate it in the manual plant, because as a system within that module, it is automatic. But when it comes to the integration with the tanks and with the transfer lines, there is no automation. So this is mismatch of automation functionality, and you really lose the advantage of having a PLC controlled system added afterwards. High dependency on operator skills and sincerity. Again, the same point, that operator sincerity is very important. Some operators get confused if there is alarm, temperature alarm, what to do. If there is an insufficient CIP, where to check the concentration of the CIP. If they are not skilled, it is a risk. So let us see why expansion. Basically, it is not only that you have a plant which is there installed during Operation Flood and it has not expanded. It's very unlikely because growth is the thing that is all the time happening in the dairy industry. We have been growing and we are proud of our growth in the dairy industry. And growth in the dairy processing is happening in two ways. One is the addition of the milk production that is happening almost 5-6% over last few years, as well as shift happening from the unorganized sector to organized sector. That's why there is a growing demand and expansion requirement for the dairy industry. So there is growing market demand. Then engage with co-packing opportunities. So now a concept is that you want to establish a facility and you want to establish a market, but if still you have a spare processing capacity, you will partner with other brands, which is very common in aseptic technology, UHT plants, that in one factory, 4, 5, 7 brands are packed. So when such multiple brands are packed, the expansion requirement and a modernization requirement, MIS reports requirement is more stringent. So it can create a wider product basket. If you are packing only the curd today, you would like to go for yogurt, fruit yogurt, you like to go for lassi, buttermilk. So the expansion has to take place. Then to reduce working hours, now we cannot say that all operations will run uh, as a default for 3 shifts operation. If we can optimize our operations and streamline the process time scheduling, then we will get better efficiency and utilization. Diversification into other products such as dairy, juice, yogurt. This is very common in the aseptic plant that sterilizer and filling machine, which is installed for dairy, will get used for juice also and yogurt also. To meet quality demands and export market, you need expansion, you need modernization, and this is not driven by us only, but also driven by the stringent quality requirements of overseas market. So why to automate? Let us see. New dairy plants coming up are invariably automated for production and CIP. But why? Because it gives the distinct advantages of hygiene, distinct advantages of better efficiency, and many people think that automation is extremely costly and it is beyond my reach. But we have done case study with our customers and we have found out the marginal extra money that you invest in automation can be recovered in less than 3 years' time. So this is quite attractive and acceptable ROI for most of our dairy processors. Existing plant control can be automated and semi-automated. It's not that we are recommending that 100% automation in each and every area, but yes, hygienic monitoring of even semi-automated equipment should be done, like the cream process, cream transfer, butter transfer, or butter to ghee and ghee making. Those may not be 100% automated, but we can still do the monitoring and CIP control in these areas. So end result, we should have better productivity and better equipment availability, because you can plot and understand which equipment is engaged for how much time and which equipment was waiting for CIP for longer time. So desired level of plant hygiene, of course, we will get, because nothing is open, nothing is handled manually, and the CIP also is happening in place. So you are not opening any piping or any flow plates to do the physical cleaning. And utility monitoring, you can plan section wise or on a broad plant level how much steam is consumed per day, how much electricity is consumed, how much water is consumed, and how I can arrive at my per liter cost of processing. Why automation actually? So this automation gives numerous benefits. In the automation, you can do a queuing function. Now, in manual plant, you have to either use the traditional plug valves are using flow plates to change from one tank to the other tank. Once one tank is empty, you want to shift, you have to open the connection and it becomes unhygienic. But through all clusters in automation, you can just keep the tanks in queue function so that once the tank reaches low level, the next tank which is queued will take up the production and there is no interruption in the production for sterilizer and pasteurizers. There are interlocks like if there is a high level, then the production will stop. If the loading will stop. If there is low level, then there will be alarm. If there is no low level and still CIP is requested, CIP will not happen because the program will remember there is a product. So these kind of alarms and interlocks are very, very essential for peace of mind for the operators and production. Product recovery by water push. You can't have multiple location and too many side glasses. So physically verifying the product path and also draining the water at right time is not possible. So either there is a dilution or there is a product wastage. But in automation, you can precisely control how the water flush is happening and how the product complete milk is getting recovered into the tank. And also during unloading, you are completely draining the product from the system. Alarm handling, if there are any alarms related to the critical control parameters or maybe the utilities, these alarms are logged. Event logs means if the alarm was critical and action was taken, that is considered as an event and it will go in the MIS reports. All the critical errors are handled and reported, and there are critical, non-critical, various types of errors are segregated, and based on the severity of the error, those are reported. All functionalities and all parameters cannot be made available to everyone who is handling the automation. So we have different password levels. The operators will be given enough rights just to run and do the cleaning of the plant, but they will not have rights to change the critical parameters which are important for HACCP point of view. So these parameters are controlled by only the production manager and supervisor, and that is they have different password levels. So equipment status, like if the tank was used for whole milk and it is not CIP clean, then next time, even if you want to load the milk, it will not be possible without doing the CIP. So these are the advantages of automation. And see the flexibility. If given a chance, the our unskilled operators want to transfer milk to any silo. If there are 5 silos, they want to utilize all 5 silos as a pasteurized milk silo, skim milk silo, raw milk silo, and then they end up with heap of pipes. And only supercomputer can understand such kind of complexity, and they will only be tracking such kind of connections. But humanly, it is impossible. You see the other picture where unhygienic connections are made, and there are plug valves used in CIP. Plug valve in CIP is a big risk because hot uh, detergent can shower on a operator or nearby people. There are loose connections. There are chances of leakages, chances of wastage. Again, too much flexibility. But this all should transfer into a properly engineered, properly designed, properly well thought automated plant where this flexibility is addressed, where the production safety is addressed, the CIP and product segregation is addressed. So this is an example of semi-automatic plant. If you see the flow plates here, the flow plates are used because the batches are quite small, but still those flow plates have sensors so that the product and CIP connection will not get intermixed. So this is a typical installation for a curd milk tanks. This is a automation console from in the automation room where you have server, you have SCADA PCs and UPS and everything. And operator has the visibility right from the tanker up to the cold store.
Yeah. Yeah. Good afternoon once again to all attendees and the participants of this particular webinar. I thank, of course, Nikhil for my kind introduction and Mr. Mahajan to take us through the needs of modernization and expansion of the dairy plants. This is a very, I would say, topic that is close to every dairy owner and a dairy producer. I can say with all my years of experience in the dairy industry, whenever a plant is set up, whether it is earlier times or now, there's always a need to expand the plant or modernize the plant, because by the time they have the plant up and running, there is a new technology is coming in, and producers are there in the market with better products and made much in a much efficient manner. So that and it be the need of the people who have already set up the plant to upgrade the plant. So now when we talk about modernization, let me say a few things, like in the sense, when you say modernize a plant, it could also mean automating the plant, or it also could mean actually refurbishing or even upgrading the plant. These are all terms that are used in terms of getting what you need in terms of the plant to go ahead. So I will take you briefly through basically how we go about what is needed to do to go about doing the modernization and the expansion of a plant. Now, having seen the earlier slides, that yes, you as a ready producer, you feel the need to modernize or expand the plant. There will be still some very few very we can say questions which can be where which will has to be answered for the producer to really take the next step. There is always a fear that by modernization there will be one is of course I had to spend a lot of money, and they don't see immediately the returns on that money immediately. So I mean, now as part of Neologic, it gives me a very pleasure to say that we have actually a very good team and skills in this particular activity of plant upgradation or modernization, and we work very closely with you as customers to make this happen. Definitely, and as you as a producer you will not take the next step unless you know the return of investment on that whatever investment that we set out to do. So we will help you with working out that kind of returns on investment or ROI to say that, so that you will feel, then you will be inclined to take the next step ahead. There's also a few questions, both as a dairy owner and your own team as well, about the fears, I would say, or challenges of modernization. We should address that before we take the next step as well. As a dairy owner, you will be also thinking that since the upgradation will mean some plant stoppages, I will have a loss of production during the time. And I can assure you that in almost all the cases that we have undertook the modernization or upgradation or even automation, we ensure that the dairy doesn't stop producing at all, and it is done very deftly with different stoppages in the plant at the right time to make sure that there is no loss of production. There's also a way of trying to plan out the entire plant stoppages by building up the inventory to have plant shutdowns for doing this particular actual changes in the plant. Of course, it also means that we had to do a very thorough design and engineering of a particular plant upgrade to see that the plant stoppages are minimum, and most of the work is done offline, either in a workshop or at your plant site, before actually cutting the pipes or the wires and the plant going into stoppages. Yeah. Next. Yeah, there's also many times we feel that as a dairy owner, you will feel that I want to keep the investment in a modernization to the or expansion as well to the minimum possible. And one of the challenges is that either you don't have space in your existing plant area, or the building itself is already occupied. And how can I go and doing adding equipment or adding certain pipelines or wall clusters for the automation? This is where we try to come in. We try to do a complete analysis of your existing facilities, see or your layout, and see how it can be optimized or changed to the minimum possible extent, so that the new equipment or the new valve clusters can be accommodated. And of course, sometimes the equipment can be taken to a higher floor or taken on a platform. And of course, we have to work very closely with your engineers and your civil architects as well out here. There's also the last question about what your production people also will be facing a loss, that once the plant is automated, the existing manual operators will find themselves out of job. We possibly can address that by upgrading or training your existing operators to run the new modern plant. Now, going ahead in terms of constraints, we also had to initially look at how, if a particular expansion needs utility generation, expansion of that utility generation, we had to look at how that can be done with minimum in the given space available and in the minimum possible investment. It may mean upgrading the existing utility equipment, and that we'll have to study how can that be done. Moving ahead, it is actually also that sometimes when you want to reduce your investment cost or rather utility cost, you may find that existing right now you are actually having high steam cost or high fuel cost, and your plant doesn't have condensate recovery. And that's where it may mean reworking the steam distribution or introducing condensate recovery, and that is something that we have to look at it in a very smart manner to how that can be introduced into the existing plant. And I already said training your operators is a very important part, and we have a necessary training programs also at our end to train the operators, your existing operators who are doing manual operation, to bring them up in terms of their level knowledge and level of doing operating an automated plant. Now, actually, the methodology of upgradation. Now, these are of course very generic steps. Each from plant to plant, it can differ. But I would say when somebody sees in a way agrees or sees a need to upgrade or expand the plant or modernize the plant with automation, one has to look at what is the existing issues you are facing or problem areas you're facing which you would like to address it, and that particular upgrade will actually solve the problem. So it is very important to identify those issues, and in what way, what is that we can do to address that issue, and once you do the upgrade, that problem will be resolved. So it is very important to do that. And of course, one has to look at section by section. One need not go do entire plant upgrade at one go. Definitely not. That is not the way to go about. It has to be done section by section, and it has to be done in a place where it actually has your maximum pain point, where either you are having product losses or having quality issues, or your utility consumptions are higher and you want to address those issues. Um, Having said that, again, when we said that we need to look at what exactly is your pain points, it could also, as we know that the new plants that are coming up are automated or having a high level of hygiene, though those producers are their products are actually meet the market requirements both from a consumer needs as well, because the consumers are getting very quality conscious as well as food safety conscious, and your product will not be able to meet the requirements there. So the identifying that your possible loss of market, either now that you already lost it or in future you want to lose a market, is something that you have to find out where in your plant you need to you are facing an issue or you're having a product quality issues, and we can address that together. Now, once we decide that, yeah, this is the kind of this is the upgrade you'd like to do, and this is what you feel that is needed by you, and you decide that this is a kind of a broad investment. Possibly we can agree upon that this is what will be needed, and once we decide that you plant upgradation, you will have to share your existing plant information data like your PNID, the layout, the piping configuration, the existing processing equipment, packing lines, the specification of those equipment, as well as some data about your utility consumptions. So once you share all that data, we will be able to quickly analyze, okay, what exactly is the problem area, and where if it can be addressed, if at all. If we see that it is possible to address that, then definitely we'll have to do an audit of your plant. And once our engineers come to do the audit of the plant, we will actually correlate or study the plant with respect to the data that you already sent, and study the other aspects about where space is available, where the plant can be upgraded, where piping can be changed without much of modification, whether space is available for introducing a wall cluster for automated operation, whether any tank needs to be lifted up to accommodate a wall cluster, and instrumentation needed, and about the amount of work involved. So once this particular audit is done by our team and along with your people at the plant site, of course we'll work out what exactly is that particular cost of doing the upgrade, and then of course submit a proposal to you. So, and again, as I said, that we when we actually start doing it, we look at what are the production areas we can cover by doing the upgrade. Whether you want to increase the plant capacity by using the existing equipment, the existing pasteurizers, separators, homogenizers, by making it work more. Also, make sure that identify whether there are any gaps in the CIP, and in what way you can introduce a proper CIP, either from a central CIP kitchen, to make sure that the hygiene level of the plant and the products it produces are meeting the industry standards, as well as a product safety point of view. As I said, we'll work out the investment needed for the upgradation with a detailed plan as to how to execute that. Because the detailed plan will mean plant shutdowns, which has to be worked out in a manner that it doesn't affect your plant production, and of course will mean having a right people at the time to do the particular plant modification and shutdowns at the time of shutdown we take. Now, once we decide, you engage with us that we need to upgrade the plant, and you give us the responsibility to do that. We will, with our experienced team who have been doing upgrades for many plants across India, we can, start up, execute the upgrade order that you can give us, and then we go about actually doing the design, engineering, supply, and actually the installations and commissioning at site. Now, the last stage, of course, is very, very important for us, for you, and for us, that whatever we had set out to upgrade the plant by way of, in terms of capacity expansion or automation to improve the productivity or improve the hygiene level or CIP, the CIP level of the plant, we have to make sure that that particular the advantages or benefits that you wanted out is actually you are actually getting that, and we will of course together make sure that is something that is proven, and we validate that at the end of the day. So that's a very brief, we can few steps of how we'll do it in terms of the upgradation or the modernization of the plant.
Exactly. Thank you, Mr. Kashyap. Actually, I would say that the mindset in India is we don't throw away even the parcel that we received in from Amazon, the carton of the parcel. And it's difficult to convince people to get rid of equipment that is costing lakhs of rupees.
Yeah, of course, exactly. Other when from a producer's point of view, it's also important that the lakhs of rupees that they've spent on the equipment when they purchased it, they like to use it as much as possible. 10 years, 15 years, 20 years, still it gives a commercial, it is commercially viable. But of course, operating a very inefficient equipment is not really advisable. But okay, till they actually set up a new plant, upgrading the existing plant becomes a need of the day, and that's where I think we can help our customers out in achieving that
Yes,
end
yes,
actually.
yes. Thank you. In continuation to the discussion so far, I have taken here a case study about the modernization of existing dairy plant at Sangam Dairy, Guntur. So, little brief about Sangam Dairy. Sangam Dairy is located at Vadlamudi, that is 21 kilometers from Guntur, and Sangam Dairy is one of the most renowned and trusted dairies in southern India. In 1977, under the Operation Flood, NDDB has designed, installed this dairy for Guntur Cooperative Milk Union, which was known as at that time, and now it is a body incorporated as Sangam Milk Producers Company, Sangam Dairy, in 2013. So they are known for their milk and milk-based products, sweets, beverages, savories, spices, bakery, and many other products they make. With growing demand, Sangam Dairy kept expanding their processing capacities. Initially, the plant was suitable for maybe 1.5 lakh liter when NDDB installed it. But then, over the period, Sangam Dairy went on adding the equipments into the same process hall. They went on adding some tanks, silos, and a situation came that further addition of capacity is not possible, as well as they were losing the track of the piping and hygienic process expansion. So, with a limited processing capacity in 2018 as 4 lakh liter, they had a plans to expand the milk production up to 8.5 lakh liter because they could foresee the demand. What challenges they faced in expansion is the processing lines used were fully manual, even though the pasteurizers afterwards were taken on PLC control, but still the entire plant had required too much of human intervention, too many flow plates were there. Due to maintaining high hygienic standards was also difficult. Space constraints, not a single corner was available even to add uh, even a chiller. So limited scope for civil work was another challenge because this building was made in 1974 to 77 when the dairy started. And all around there was a powder plant. There was on one side the area was blocked with silos and road and everything. So they thought that to go for expansion, they will have to go for a completely new greenfield building and a greenfield project within the same campus. And a greenfield project starting from scratch may take more than 2 years. That was the apprehension of the management. So we studied Sangam Dairy in detail. We understood that what are their pain areas, how the energy is consumed more, how the per liter cost is going more. And another fear that they had in mind was to utilize the existing equipment, they will have to go for a big shutdown. And dairy is a 365 days operations. No shutdown is possible. So we studied this project and we understood that there is a possibility of doing expansion in a running dairy. So this is what you see here is a sketch of partial area of the old dairy, and the colored area that you see is the old process hall where there was absolutely no space, and there were tankages, big 30,000 liter tanks, and all those tanks indoor inside the dairy, and utility lines were laid as and when required. Additional lines were laid, additional tappings were taken. So no place for expansion, and the old tanks didn't have the enough chance to put up the modern instrumentation and valves. So we suggested them to go for an annex process hall. So next to the existing process hall, we suggested them that they can go for just additional process hall, and they don't have to go for a completely new, different building and different campus. So this is how we suggested uh, additional process hall, and we shifted one by one their silos, their equipments. So the green part that you see is the new equipments added for the enhanced capacity up to 8 lakh liter. New CIP was commissioned, new pasteurizers was commissioned, the entire piping wall clusters were established. Some of the silos which they could spare, those silos were installed, new silos were installed, and we started first the operations with new equipment in the new premises. And as and when there was a shutdown over the night, we shifted some of the equipments, and fortunately we could do it without a single shutdown, without much challenges on the production. And I can proudly say with almost nil product loss. So this is how it looks like. The old dairy, there is just a corridor in between. So the old superstructure, which is in good condition, was not touched. So we created a process hall, and this is, I can say, is just 20% additional construction they had to do as compared to the new greenfield project. And today they are utilizing capacity not 100%, but even more than that, because there is automation. They know where is the spare capacity available, which tank is empty, which tank can be utilized for more number of times and silos. So these are the solutions that we provided at Sangam Dairy. Automated 4-circuit tanker milk reception, tanker CIP, just adjacent to the tanker reception, additional silos, wall clusters, separate wall clusters for pasteurized milk, as well as its delivery points to the packaging station, byproduct section. Byproduct station is, by the way, 200 meters away, and still there should not be any product losses, which can be achieved only by automation. Dispatch to powder plant. So these are some of the photographs of this is a 4 tanker unloading and 4 tanker CIPs base. These are the new ultra modern pasteurizers and separators of alpha level. Big wall cluster. That's all. So this is how we have presented a case, and we have presented and discussed the challenges in modernization, methodology, how we should go about the modernization, and a case study.
So, shall I take the first question?
Yes, please.
Yeah. So the question is from Mr. Murthy. Is it possible to do the expansion and upgradation without stopping the existing running dairy? And normally, how many days this will take?
Yes, it is definitely possible, as we have shared in the case study, that it requires micro planning. It requires a thorough understanding of the operations of the dairy, and based on the new equipment and old equipment utilization, we can do the micro planning, and without stoppage of the dairy, upgradation is possible. And how many days it will take, it really depends on case to case basis. Sometimes you can ship the equipment just overnight, but before that, we have to make a lot of preparations that the new establishment, new utility lines are already laid and ready and tested to add that machine suddenly. So it is a case to case basis, I can say.
Sure. The next question is from Mr. Ananta Dhodre. Which sensors are used to know whether some part is CIP cleaned?
There are quality parameters, and there are some um, fluorescent sensors where you can detect which part is not clean. But there is nothing like a tank mounted sensor that will tell, hey, I am unclean. Yeah, you have to go physically and verify. Maybe another very trusted example is taking swab test, but swab test is not a quick test. Always.
Next question is from Mr. Akshay Mathwar. How to evaluate that my equipment is not designed hygienically?
When you have repeated challenges about the cleaning, when you have market complaints, and when you are not able to maintain the isolation between the production and CIP, and you have to wait hours together for the CIP because there is a product in the line, that means you are already having problems, and you need a physical isolation by way of having automated mixer walls, or by way of having some wall clusters or flow plates. But physical isolation must be done, and then only you can ensure, as well as you have to have MIS reports about the production parameters. If you do not have report, then you are struggling in dark.
Just to add out here, I mean, when challenges of equipment not being hygienic comes by way of product quality. For example, let's take the case of a pasteurizer. A pasteurizer is cleaned in line in the pasteurizer for days together, and then once the CIP is over, it is taken, it is clean. But it's very important as a user to once in a way, it could be once in 6 months or in a year, to open up physically the pasteurizer and see if the plates are got cleaned. And that's the kind of validation protocol that the user has to put in place to make sure that the your existing CIP regime is being effective, and the equipment are getting cleaned. And of course, the same goes with all other equipment which are cleaned either inline, they have to be validated. Those equipment, of course, that are cleaned offline by actually every time. They have to be open. You have to physically check and that they are cleaned before it goes into next production.
Noted. Next question is from Mr. Amit Saha. Is there the way to benchmark with global quality standards, the existing and modernized dairy plants?
The hygienic standards are very much defined for the product, and each product, their bacterial load, how much bacterial load is allowed, and what type of load in a cold chain product is defined. But when we are discussing about the quality standard of a dairy establishment, then I can say these are very much global standards. The safety protocols, the interlocks, the MIS reports, those are very much standardized. And there is when we do automation of any process plant, not only dairy, but any process plant, we follow the S88 and S90 standard, which is the global benchmark for the automation. So the equipments and systems that we design here in India are no way different than the equipments used by Arla, Nestle, Lactalis in Europe or Americas. So the standards of automation and the standards of interlock are same.
Indeed. Next question is from Mr. Mohan Raj. Have you handled any plant which handles milk and juice in parallel?
Yes, most of the plants where we have UHT, aseptic technology, long shelf life product, those plants are equipped with juice as well as milk. Milk being more challenging, generally all the plants are designed for milk first and then juice is possible. But we have to take into account the viscosity, the fiber content, and salt content, and so many other parameters. So beforehand, if we are given that parameter, then such plants can be designed. Anyhow, the low acid product blending and product preparation and juice product preparation is different, even though the sterilizer and filling machine is common.
Okay. Next question is from Chaitali Keskarji. How feasible is modernization for small or medium scale dairy plants in India?
Small and medium, basically, these are very relative terms. But if given a choice, I would say medium dairy is the dairy which is handling 100,000 liter milk. And I strongly recommend that any milk plant which is having 100,000 liter milk handling per day, they should go for automation. Why? You will say why? Because in such kind of a volume handling, there are multiple operations, multiple handling, multiple times you are utilizing the tanks, multiple line you are going to use the transfer lines, loading lines, unloading lines. So keeping track, keep doing CIP manually is difficult and automation is justifiable. But in very small plants like 10,000 liter plant or up to 50,000 liter plant, the cost of instrumentation and automation is much higher than the basic equipment cost itself, and then it becomes a challenge. But if you are making exotic products, very special products, for which you get very good uh, consumer rates, then you can think of that also for small plants.
Thank you. Another question from Mr. Mukesh Pathak. Is integration of milk process plant with refrigeration and boiler possible and successful in order to optimize the utility consumption? Usually, no recovery or less recovery of condensate is noticed. Also, waste heat is not recovered.
Yes, this is a really wonderful question. Even though the hygienic plant operations and controls on product side is a separate area, and it is the HACCP standards are different. The projects that we do integrate the reporting side of the utilities, how much steam is consumed, how much water is consumed, all these things are recorded and reported so that the management know how much is the cost of per liter of processing. That is one part. But when it comes to the operation of refrigeration, operation of the boiler, I would suggest these are also modern. There is also modernization in that field, and to handle the complexity and handle it with efficient way. So if the boiler has its own PLC panel, if the refrigeration system has its own PLC panel, those PLC controls can be integrated into the centralized SCADA system and MIS reporting. So you will get report at one point. You will get alarms at one point.
Okay. Okay. Next question is from Mr. Ananta. What are the additional features in the modern ultra centrifuge and pasteurizer shown in the slides?
Basically, I would say the heat regeneration efficiency is monitored, the operation, the CIP is monitored, CIP cycle is monitored in the pasteurizer. Um, there, there is an event log whenever the product pasteurizer is going into the recirculation mode, so that event log is monitored. So all these features are there, and we use the latest technology of alpha level in efficient plate heat exchangers design. In centrifuges, there is tremendous modernization happening in the centrifuges. Nowadays, there are centrifuges where there are smooth plates, and it increases the hygienic quality and hydraulic capacity of the centrifuges, and also it has reduced the power consumption in the centrifuges by almost 30%. So a lot of development is happening here.
We have question from Mohan Raj. Are you involved only in restructuring the plant, or you have the solution for automation and dashboard monitoring?
Basically, today our topic was modernization of the existing plants, but our first love is to set up modern greenfield projects. Of course, modernization is possible, but automation is just not related to the reporting or collection of the data. Collection of the data and fetching the data and putting it in SAP is a small part of the whole process, I would say.
There is one more important question about can you conduct the process audit for our plants and suggest the upgradation changes in current operations?
Process audit is a broad term. Basically, you will have to share what are your concern areas or pain point areas, and what are the chances of failure you have seen, and what is you are looking forward to in future to expand or in renovate. So based on that, we can give you primary suggestion, and if we both agree, then our experts can visit and do that kind of audit.
Okay.
We need to do some homework before visiting. That's why you need to share more concern areas and data.
Next question, I think Mr. Kashyap can address. To what level will my plant solids losses come to if I automate the plant?
Can you come again, Nikhil, with the question?
To what level will my plant solids plant solid losses come to if I automate the plant?
Yeah, I mean, a good question here. One of the primary reasons for bringing in automation is to reduce your plant solids loss. Essentially, in a manual plant, this is either not controlled or is very difficult to control that. So and one of the very primary areas of justification and its basically return of investment is recovery of solids and minimizing that compared to what it is right now. Now, what is important is before we start, as you said, that we need to conduct your existing pain points and how you are operating the plant. What is your mass balance? How much are you recovering? How much are you getting into the plant, and how much you are recovering by way of the finished products? Once we do a mass balance, we look at where are your solids losses happening, and that's of course something that is an exercise that we'll suggest. Yeah, it has to be done by you at your end. It may take number of days to do that. Once you have an averaged out figure of how much your existing solid losses are there, we'll have to identify where your solids are getting lost and what is that we can do to in terms of recovering that when you are actually automating the plant. Now your existing solid losses may be existing can be more than 3%, and sometimes it can be even more than 4 or 5% depending on the byproduct you're making. So we have to look at where we can control using automation, and then by using we can say recovery of the mixed phase during product transfers, or recovery of the product in a recovery tank and reusing that product. There are many ways of doing that depending on what your existing product safeties are. There could be certain manufacturers who don't want to use the rinse product for the original product, but they would like to use it somewhere else. So these are to be arrived at. Definitely, it can be reduced, but there is no specific figure one can put it. But definitely, the automation that you do has to result in a recovery of solids or reducing the your solids losses. That's very important. So, if you have any specific data about your plant, be feel free to share it with us, and then we can get back and with our response to that and start working on that.
Noted. So we'll take one more last questions. We have received a lot of questions, but we are going out of time right now. So we'll take one last question. So one similar questions we have received from a lot of people, like what is the qualification required for operators in automated dairy? Is there any typical training required? Specific training is required?
Yeah. Basically, the operator who understands your regular manual dairy plant understands the milk process. We consider he understands the commands in terms of what parameters he has to maintain in the plant, like the CIP parameters and the pasteurization and other machine parameters. If he understands that and he can read and understand the meaning of the alarms, he is a good operator. We can train him for automation. We have a facility here in our office. When we implement a automated dairy project, we encourage customers to employ the operators beforehand so that they come to our office. We train them on basic maintenance in the pasteurized PHEs, separators, valves. We train them on the automation commands. We have a facility here where they can understand the different menus of automation. They can literally play here rather than playing in the live plant, so that they are comfortable and it is not a cultural shock when they go into their plant and start operating. Sometimes we find that they are so much excited that they want to take charge from our engineer like a new driver to run the plant, and it's easy. Sometimes we get a complaint from the operators that the plant is so automated that करने के लिए कुछ नहीं. So it is a good compliment, I would say. करने के लिए कुछ नहीं, because they are just monitoring the screen and operation. Okay.
So can we have the next slide, please? Yeah. So these are few of the upcoming webinars. New age dairy plant automation, latest trends in aseptic milk processing, significance of AI in automated food processing plants. And also you can see, you can go through our previous webinars as well on our official YouTube channel. You just have to search Neologic Engineers in YouTube. Also, I've pasted the YouTube channel link in the chat box as well. Yeah. Can we have the next slide, please, sir? Yes. So also, I would like to give a heartfelt thanks to all our esteemed speakers, Mr. Ravindra Mahajan and Mr. Shirish Kashyap, for sharing their profound insights in today's session. And finally, sincere thanks to all the attendees for your active participation and engagement. Let us continue driving innovation and excellence in food processing industry. We will look forward to seeing you in the future webinars. Thank you once again for
Thank you,
joining.
attendees, for asking
Thank you.
really wonderful questions. It shows your passion, it shows your interest, and we are there to help you. Thank you.
Thank you all the
Thank you.
attendees for
Thank
your
you.
time. And please free to write to us on all your needs for modernization operation. We are there to work with you and help you out.
Yeah.
Thank you.
Thank you. Thank you all.